The Earth is a living thing. It has naturally cyclic behaviors.
To Richard Peltier, one of the world's leading authorities on the deep Earth, our planet is like this. Silly putty.
The deep interior of the Earth is a material which is, it looks like an elastic spring when you apply a force to it. But if you continue to push, if you continue to maintain the force, eventually the interior begins to flow just as if it were a simple fluid.
The Earth is a mosaic of tectonic plates that move around atop this viscous, silly putty-like mantle. When heavy glaciers press down, it compresses the silly putty underneath, tilting the plate. When the ice is removed, the plate loses its tilt.
Even though it is 7,000 years since the last remnant of these great ice sheets in the northern hemisphere disappeared, the land in the Hudson Bay region of Canada, for example, is still rising out of the sea at the rate of about 1.5 centimeters every year. The entire east coast of the continental United States is currently sinking into the sea.
Peltier developed the first comprehensive, detailed theory of sea level changes, using large supercomputers to crunch together a large array of data never brought together before. Governments, insurance companies, and even the Nobel Prize-winning Intergovernmental Panel on Climate Change use his models to plan for our changing climate. One part of the model predicts how the Earth wiggles itself back into equilibrium when glaciers melt. Sometimes the predictions are counterintuitive.
We have much more to fear in the northern hemisphere from the melting of the West Antarctic ice sheet in terms of sea level than we have to fear from the melting of the Greenland ice sheet. When we place a massive quantity of ice on a continent, the gravitational attraction, the massiveness of the ice, will have pulled water from the ocean into its near vicinity. When the ice begins to melt, not only are you adding then water to the ocean basins, but you're also releasing the gravitational attraction.
Peltier came from a family of modest means who believed in education and hard work. His science career began at the University of British Columbia in Vancouver. At first, he wanted to become a geologist. He worked every summer for a company staking mineral claims in the Northwest Territories.
If you ever made the mistake of walking around the circumference of a lake near the shoreline at that time of the year near breakup, you were bound to be totally infested with black flies and mosquitoes and so on. And it was really that experience which determined that I would actually become a theorist.
He got his PhD in physics at the University of Toronto in 1971. And after a short stint at the University of Colorado, he returned to the University of Toronto, where he remained throughout his career. He now heads the Center for Global Change Science at a large new supercomputer center. Along the way, he provided deep insights into many mysteries of Earth behavior. For example, continents come together and drift apart every 300 to 400 million years, a process using convection.
To build a theory of the convection process, you need to understand the silly putty nature of the mantle itself. How sticky is it?
Looking at a far more rapid time scale, Peltier explained why over the last 7,000 years, sea levels in some places changed more than previous theories allowed. He found that these anomalies were caused by changes in the Earth's rotation induced by changes in glaciers.
The shape of the planet is continuously changing even now as a consequence of this redistribution of mass on the surface. There are 4 bullseyes that are emplaced on the surface of the planet, 2 of which have gravitational potential increasing and 2 of which have gravitational potential decreasing.
As Peltier dissects the now disrupted pulse of the planet, he remains optimistic about what the future holds.
The increasing load of greenhouse gases which humankind is adding to the atmosphere has basically turned off what had been, for 1 million years of Earth history, a massive cycle of glaciation and deglaciation. We are going to have to get our collective will together to face it. I think that what will happen is a is a massive investment of intellectual effort that will lead us along an entirely different path. And I think this path will be nothing if not extremely creative and take us in a much better direction.
The 2010 Bauer Award and Prize for Achievement in Science is presented to W. Richard Peltier for fundamental advances in the understanding of Earth systems by demonstrating profound interconnections between surface climate variability as evidenced in the hydrosphere and cryosphere, and the internal properties and dynamics of the solid Earth.